As you may know, many modern generational people often try to maintain a healthy diet by buying sugar-reduced or sugar-free products. Doing this can help make the food healthier overall, but it can alter the taste of the food, which is why some manufacturers use artificial sweeteners such as sucralose and aspartame as a substitute for lost sugar. However, artificial sweeteners have their own disadvantages, such as causing diseases and not being able to replicate the exact taste of conventional sugar, which is why I'm here to discuss a new sugar substitute that not only has an identical taste as conventional sugar, but is also calorie-free as well as the chemistry behind it. Sugar is a type of carbohydrate. When humans consume carbohydrates, it gets turned into a type of energy called adenosine triphosphate, or ATP. If excess carbohydrates are consumed, however, the unused energy will be converted into glycogen and then into fat, which is why some people try to reduce the consumption of it. There are multiple types of sugars, such as glucose and sucrose, which are often used to make sweets. Sucrose doesn't have any other spatial geometric differences in its molecular structure, stereoisomers. However, glucose does have two enantiomers. Enantiomers are just pairs of molecules that are mirror images of each other, but aren't exactly identical. For instance, our two hands are mirror images of each other. However, they cannot be superimposed in any way. Thus, if our hands were molecules, they'd be considered enantiomers. The enantiomers of glucose are called L-glucose and D-glucose. These enantiomers have the same physical properties such as taste, smell, melting point, boiling point, etc. But there are a few differences between L and D-glucose. For instance, D-glucose rotates polarized like clockwise, whereas L-glucose turns it counterclockwise. Another difference is that D-glucose can be found in fruits, vegetables, plants, and animals, and can be digested by the human body. L-glucose, however, can't be found in nature and can be digested by all animals, including humans. Thus, it is considered to have 0 calories. My idea is that if we are able to synthesize L-glucose efficiently, we can potentially use it for sweets and other glucose-containing products. This way, we can not only reduce the number of calories in these products, but also maintain the flavor profile and sweetness of them. To sum everything up, if L-glucose could be produced efficiently enough, it would likely replace artificial sweeteners due to its extreme similarity with conventional sugar, glucose, and its non-caloric content. This would revolutionize how we sweeten foods and improve the diets of many. My name is Dhanaad, and thanks for listening.